Good evening, everyone, and thank you all for joining us today. My name is Rashmita, and I am the event planner for Microsoft Reactor India. The session will run over the next 60 minutes, including Q&A. But before we begin today's session, please take a moment to read our code of conduct. We are all here to learn together, so please be respectful of other people's views, understanding of differences, being kind and considerate in the way you engage. The chat section will be open throughout, and we do encourage you all to participate. So please feel free to drop all your questions in the chat section. I would now like to welcome Sai, our speaker for today's session. Sai is an AI research engineer. He is also an author, currently writing a book on AI agents with Manning Publications. But for now, I will hand over to Sai to begin the session. Let me bring him into the stream. Hey, Sai.
Hello.
Hi.
Yeah,
Yeah. Your presentation is up, and yeah, the floor is all yours.
thank you. Thank you so much, Rashmita. Good evening, everyone. My name is Sai Yashwant, and I'm here to present this session where I'll be talking about AI agents, but from a different perspective. How to build scalable agents, and we will be talking about a small framework. We'll be talking about how to build what are agents, first of all, and then how to build good agents. And then I'll show you a small framework which I built, which I use to build agents in my startup. And then from there we'll talk about how agents would you would interact with agents in the future. So before we begin, a bit of introduction about me. I am Sai Yashwant. I am a final year student at PES University. I'm also an AI research engineer at this UK based startup called VOC. We're a very early stage startup. Before VOC, I worked as a summer intern at Composio. Composio is like one of the best startups currently in the AI agent space. They're basically like toolset providers and authentication providers for agents. Apart from that, I also am currently writing a book on multi-agent systems with the founder of VOC. We both are currently writing it under Manning Publications. Along with all of this, along with my friend, we founded Turi Labs. It's an independent AI research lab where we do a lot of experimentations. We build a lot of crazy projects. And yeah, previously I gave a session in Microsoft Reactor on internals of AI agents, where we went one or two levels deeper and discussed how AI agents work, what they are exactly. So yeah, one last line about me is I experiment a lot, I fail a lot, and that is my nature. So even Turi Labs was part of that. And yeah, all my social handles are in the presentation. You can check it out. You can read my blog. So yeah, let's get started. So the agenda for this talk basically is I will start with a very basic intro on what AI agents are, and then we'll see some good practices on how to build agents. The whole topic is build good agents, build scalable agents. After this, I will show you a framework which I built on on top of AI, OpenAI assistants. It'll be a small walkthrough where I'll just show you the code. I'm not supposed to show the whole thing since I built this as a part of me working at OOC, but I can show you some snippets. After that, this project which I built, which I'm building currently with my friend, which follows all the good practices. So it'll be like a good refresher. It's a project which it's basically an AI agent which builds more AI agents. So it builds them using all the good practices which I learned over the past 10 months, 11 months or something. And finally, we'll be talking about how you would be using AI agents in the future, how AI agents would come. So how they would replace or maybe transform your traditional SaaS. So that would be the end of the session. So let's get started with the first topic. A very basic, humble intro of what AI agents are. So you might have heard of AI agents. You might have seen a lot of demos. You might have heard of Operator, which was released, like last week. So if so, just for me to give you a simple example, a small definition of my own on what AI agents are, and then we'll just see how they work internally. Just a single slide, just to know some prerequisite stuff. So an AI agent is like a human. We humans, we have arms and legs, and we have a brain. We take in input using, our ears, and then output is me speaking. So that could be one output. Similarly, AI agents, they have a brain, that is LLM. They take input and they give out output, and they can perform some sort of actions, like sending an email, sending a WhatsApp message, putting a post on LinkedIn, putting a post on Twitter, stuff like these actions we do using our hands. We type, we walk, we run, we play football, or we send email, we use our hands. Similarly, AI agents have something called tools. So components, so an AI agent basically consists of uh, a personality, tools, a task or a goal at hand, and some sort of context on what or how to do it. That's what an AI agent is. So an AI agent essentially is just an LLM. Like I told, the brain is basically an LLM. So it's an LLM which has a personality, it has a task which it needs to finish. It'll have some context on what or how to do, and it'll have some tools at its disposal. So like we have arms to type, so they'll have some sort of tools to do some sort of tasks. That is a very simple definition of an agent. So yeah, the components of an agent, they have limbs which are tools. Brain is basic LLM, and the stronger the brain, the better the LLM could be. That's what operator is. Operator runs on O1 or O3. I'm not wrong. But yeah, and then memory. They also have memory. That is also one more important part. Traditionally, LLMs have this thing called context size, and their memory is limited to that. But you can also create some external memory sources, and, the concept of RAG, and give them some memory. This would, and then give them a retrieval tool to use this memory and do sort of actions, context, whatever. So yeah, how does an LLM act like a agent? This was the whole topic of my previous talk. To summarize it in like 5 lines, there's this thing called reasoning and action. So you're telling your LLM. So basically, an LLM is an ML model which takes in an input and gives out an output. It takes some text and gives an output. You would have interacted with ChatGPT or Claude or whatever. All those have some sort of LLM under the hood. ChatGPT is just a web, layer on top of it. So you give an input, it gives an output. This output seems very, correct according to the input. It semantically predicts the output which you get. That's how LLMs internally work. So you can make this LLM think in a series of steps, and this whole process is called reasoning. You might have seen DeepSeek R1, which is a reasoning model. It If you give it a input, it gives an output, and the output consists of some sort of thought and then a final answer. So this thought is basically the reasoning trace which it does. It's called chain of thought, and your LLM with chain of thought can think, and then with tools it can do action. So that is what reasoning and action mean. So a chain of thought, an LLM with chain of thought and with a set of tools, and it'll do all the stuff. And that's how Crew AI works, and a lot of other frameworks like Autogen, all of these, they work in the same manner. So a simple example of what a multi AI agent system could look like. This is a project which I built back in June. This got very popular. This got like some 200 stars on LinkedIn or something, on GitHub, 200 stars on GitHub, and it became kind of viral. And the main thing what it does was it creates a code for you. It's like an engineering team on its own. You give it a task, like let's say build a backend for a banking application. It would create all the files and give it to you. Similar to how tools like bold.me or lovable.dev, how they work. Similar to that. But this was done before them. It's also a very prototype version, so I did not improve later. But yeah, there's a basic thing. You have four entities called architect agent, programmer agent, tester agent, and a reviewer agent. These four are agents. These four work together to finish a task. So the task would be the user giving some sort of problem to solve. It could be like build a tic tac toe project or build a backend for a banking application. So this problem statement, the input would be taken by your architect agent. It'll break the input into multiple steps, create a design document, pass this design document to your programmer agent. Programmer agent would create all the code files. The tester would test all these files, and then after it tests, if it's everything is good, and just sends to your reviewer agent, which reviews the whole code base and gives the final output. The final output is basically a document called readme.md, which has all the ways to run the code and all. It just explains the code what it is. So this is a simple example of what we can achieve with agents, and why it's interesting to learn. So yeah, the second topic was, now that you know what an agent is, let's see how you can build good agents, how you can build agents which you can put in production, scalable agents. So I wrote a tweet long back on, if you're a beginner and you want to get started with AI agents, what to do. So my recommendation is to pick up a framework. Crew AI, there are many frameworks like Crew AI, LangGraph, AutoGen. AutoGen rebranded as AG2. There are many more. All of these frameworks are all the same. I recommend people to use Crew AI because it is easy to get started. It's very easy, the syntax and everything. So once you get started with Crew AI, look into the documentation, build an example project. Once you do that, once you can walk with Crew AI, that means once you know the basics, basics, you can start integrating some good practices, and that's what we'll discuss. So one thing is, Crew AI has these two things, right? An agent and a task. You can create a folder only for agents, and in this folder, each file would be one agent, and the agent profile and stuff like that. Another folder called task. Each file would have tasks which the agent needs to do for that particular agent. You will have another folder named tools, and then a main.py which brings all of these together. That's one beginner friendly way of building agents, good code base practices. I wrote a similar post again, and this was a little bit different. This is what I do at my startup where I work. You have almost a similar structure. You have a folder for all the tools which you write, and you have a folder for all the agents which you write. Each file in these folders would be the particular agent or the particular tool. I'm adding task and agent both in the same file. I'll tell you why. You have two other folders here: output folder and prompts folder. So prompts folder is where all the prompts for all the agents will be, and that's why we are clubbing task and agents here. So you will have this prompts.yaml file where you'll store that particular agent's prompts, and then in your agent, in whatever name.py file, you would initialize the prompts and create a agent. And the same way, you have outputs. Since your agents are expected to do something, it's better to ask them to give a structured output, a standardized output. This will make sure the error margin is brought down to very less, because with agents, you have to be okay with having some sort of error margin. And that's why structured outputs help a lot. And I think it's the norm now, everybody uses them. So a completely different folder where you store the output schema for each agent in their separate files. And again, a main.py to bring all of this together. So yeah,
Sai, we have one question
yeah,
from Rashmi. I'll just get it up on the screen for you.
yes. By tools, it's basically function calls. Functions are tools. They are the same thing.
Okay, thank you. Yeah, can go ahead.
So you know how to use Crew AI. You know how to structure the code base properly. Now let's look into some rules which I would like to call, and also some stuff which the founder of Crew AI himself tweeted. So simple rules. Step one, first rule is basically keep it simple and stupid. It's not rules, but yeah, some guidelines which I follow. Keep it simple and stupid. Easy, and make your code base such that it's easy to make refactoring changes in the future, and keep it centralized, structured, but don't go overboard. Don't create so many files so that it becomes difficult to organize. That's why the first point is keep it simple. So what the founder of Crew AI says, your agent, right? Your agent. This is more related to the prompts. It should have a clear role, and that is basically what they are. My words, I would call it personality. Your agent should have a personality and a specific goal, that is a task. So it should know what is supposed to do. The output should be declared properly. And then the last is a rich context. That is what he mentions is how they think. Basically, what they need to do, you can simply put it in the prompt, so they don't hallucinate their steps, and you won't see any bad results. This is very useful if you're building, agents in production, because the users who will be using your application, they won't be using it according to what you think they'll use, right? They'll use it, and you won't even know how what has happened, and your agents would fail, and production would be a mess. So it's always good to have some clear guidelines to be followed. So yeah, the lessons, and also there was one more post which I wrote on how to make cheap agents. So when you're building agents, they would hallucinate the steps and they would go on an endless loop or something, and it would be a mess. And we faced a similar thing. We burned close to $200. We burned $60 per day. Our monthly quota is $200 because we are a early stage startup. That's a lot for us, and we burned that in like a week or something, like less than 5 days. So the lessons learned were, keep in mind that your agents are dumb. Just keep that in mind, that these LLMs are not as intelligent as you think. They won't be doing anything, and they might hallucinate a lot. It will make them feel dumb. And then design the pipeline of your agentic workflow according to this in mind. Again, keep it simple and stupid. It's always there anywhere. Mixture of LLMs. So basically, you might have a task with some sort of complexity, a task with some sort of lesser complexity compared to a normal task. So it's better not to use the same LLM, since, I mean, if you notice, there's GPT-4o mini, which is a lesser intelligent model, lesser, it has lesser parameters. So that versus GPT-4o, which has more, obviously the cost also is a lot. It's like 90% of difference. So if it's a task which you think is not as complex, you give it to 4o. That's what mixture of LLMs. That's what I mean by that. So based on the task at hand, you assign the models from cheaper to costlier models. Prompt engineering is a crucial aspect. Writing good prompts is as important as it looks. If you look here in the tweet by the founder of Crew AI, is a similar thing. Better prompts will give you better results. And to do that, you give a clear role, clear context, um, what the clear goal, and an example of what it should be, and like how the structure of the output should be. This is how a good prompt usually looks like. You can mix and match here and there, but yeah. And to avoid hallucinations, one important thing I noticed is, give the tools which are required to your agent. So your agent would only need a web search tool and a RAG tool. You don't need to give it some tool which does something else, and because they would hallucinate a lot. So that is one thing. Least privilege principle. There's this thing in OS where this principle is applied, where each entity is only given the responsibilities which it needs, nothing more than that. And one more thing I would like to add here is, all these principles are good, but what if the cost of intelligence is brought down? DeepSeek made a lot of noise, in the last 2 weeks, and rightfully so, because the DeepSeek V3, right, that model is as good as GPT-4o, and if you compare the cost, it's 95% lesser than GPT-4o. If it's as cheap as that, we don't really need to follow all these. We can simply create agents like how we do normally, and we'll still not have, you know, we would still not burn so much cash. And DeepSeek R1 is a reasoning model on par with O1. It's still cheaper than DeepSeek 4o. It's as cheap as 4o mini. V3 is cheaper than 4o mini. So these things are not set in stone. They'll change a lot with a lot of advancements. The best thing is to keep experimenting, and you'll know what to do, what not to do. So yeah, all my posts, I write it on my blog post and it's on my Twitter, but I like to collect them on my blog, and like I just keep it there. You can visit that. And yeah, finally, so now I started with a very basic example of what an agent is, how they work and what they are. Then if you're a beginner, I recommended to use Crew AI, and then I gave some good practices which from my own experiences. Finally, we have you'll reach a point where if you keep building agents, that you will realize that these frameworks are not as good as they are supposed to be. And this is a similar problem with there's a similar problem with your front end frameworks as well. A lot of people hate on those frameworks, right? A lot of people, they say there are memes that another day, another JavaScript framework, and stuff like that will happen to this field also. A lot of people will come make frameworks. The point of frameworks is to get you started, to help you in prototyping. Once you put your agents in production, you would want to have maximum control on what they are doing, how they are working, and everything, right? So, and there was a blog post by Anthropic on how to build effective agents, and this whole talk draws some sort of inspiration from that. The whole blog post, what they summarized was, it's better to use LLM API calls to work as agents instead of using frameworks. That's what the conclusion was. It's better to use LLM calls. This is what I also wrote in a small blog post, where I mentioned how it is better to have more control on your application, and how that is not happening when you use frameworks. And that is why I built a framework on my own around 6 months ago. Like it started from I started in August, and I kept on incrementing and adding small changes. The goal is simple. Frameworks like Crew AI, they're very good. They're very good for prototyping. But the problem is you lose control as your application grows bigger, or as your user base grows bigger. So to tackle that, you need to have as much control as you can. The best way to do that is build your own framework, and or you can use LLM API calls. Although I call it a framework, it's a simple abstraction on top of OpenAI's Assistants API. So there's this thing called OpenAI's Assistants that is similar to your LLM call. So what exactly is an LLM call? It's basically an LLM which is stored by OpenAI guys in that cloud server. You send a question, it goes to that cloud server, it hits that model, and model gives you an answer. And this is how you get it back. That's the basic API. Assistance API is also similar. They provide some few more features on top of the normal LLM calls, but they're literally the same. And what I did was I took this assistance API, whatever this entity is, I added a way for you to add a personality, a goal, and tools. These three things you can add easily. And it's a very beautiful abstraction which I built. You can get started by building agents in like some 5 lines of code. So yeah, the whole thing was because Crua was very bad in production, and it was bloated actually. If you look into it, there were a lot of dependency issues coming, and that's the reason I came to this. Uh, Atlas, it's not a promotion. It's not open sourced yet. We are running it in our. It's private for us. We just use it to run our agents for my startup. But the thing I like about this is it's easy, since like it took me like 3 weeks to get started with building it. Once I built it, it's like as easy as like file writing 5 lines of code, and I would have an AI assistant. The only important stuff would be adding prompts and stuff. So the features is basically zero coupling. There's no interlinks between different dependencies. If you used CrewAI for a long time, you would know that CrewAI is not as good, and there would be some sort of problems when you add more features. These problems are basically when you run, you would get some sort of dependency issues, some conflicts between dependencies, and it'll get a lot more messier than that. So the biggest feature which I liked was it's free from LangChain. So LangChain is a group of people coming up and creating some sort of abstractions on top of normal LLMs. CrewAI came on and built on top of LangChain. I'm not sure if they actually built on top of it, but yeah, if you look at the error trace, you'll realize that there's a lot of interdependencies, and it's not really that nice. My framework has it's completely free from LangChain. It's all built on top of OpenAI's API, so it's very good. It's very lightweight. There are no abstractions with other dependencies. It's just OpenAI's API plus some other small frameworks to make the output look better. There's this thing called rich Python rich, which makes the output look colorful and stuff. So that's it. And yeah, if you look at the image, you could see how the output looks like. There are two steps to build an agent in my framework. You give a personality to the agent, and then you give a task. Literally, that's it. And you give tools as well. So you give your LLM personality, tools, and task. And you can see the image here. You are giving a profile to the agent profiling, You're giving some tools as well and a task. And this is how the output looks like. And this is one more agent, which is basically like a infinite loop chat type of agent where you can chat with it and it will give you answers. Basically, my vision was to create a persona bot. So anything chat with some personality like Elon Musk, or you could train it on my blog post and you could chat with a version of me. So that is second. These are the two agents which you can build. Second one was just for fun. I was just playing around. First one is the one which we use at OOC, and I use it in a lot of places. And yeah, this is so the first agent, right? This agent is exposed. I mean, you can run the agent using two functions. It's called agent create agent and create task, right? In create agent, you also give tools to the agent. So if you go to the code snippet, yeah, so there's create agent, which takes in API key that's like secondary, takes name of your agent, instructions, that's basically the profile, the role or what the agent's personality is, tools, what the tool should be, and the output format, some pedantic model on how the output should look like. Then you have task. Task is where you define what should be done by the agent. It's a simple line. All the code is just the making the output look good. That's it. There's just one line of code there, and you can also save the file output of your agent in some files if you can provide it. And yeah, and this again, those two were to create a normal agent. These two, these two functions are to create the endless chat loop. So yeah, to create a persona, you give a system prompt, you give a name, you give some tools, and you just initialize the chatbot and give some input. And this is a for loop. This can be customized based on your needs. This is just a toy version. The main version is these two: create task, create agent, and works flawlessly. So yeah, all of this is done. I talked about what an agent is, some good practice on how to build agents, and then why frameworks are not that good, and how I built a framework. Then now a project which combines all of this, a project which is an AI agent which can build a lot of AI agents based on whatever your need is. So yeah, the project is called YantraKarma. It's a Sanskrit name which means machine creator, something similar to what the project is. So the project is an AI agent which builds AI agents, and it does that by following all the good practices which I mentioned. So this is a small sketch which I made. This is a project which me and my friend is working on. This is a very rough sketch of what I initially had in my mind. It's called Agent Builder. So that's the initial name which I gave. It'll have three agents. It'll have an architect. It'll have an agent builder and a tool builder, similar to the Devyant project which I showed you. So the architect would take the problem statement. It would create a design document on how what type of agent should be there, what type of tool should be there, what are the role each agent should get, how the flow will be like, right? And based on this input would be given to your agent builder. Then the agent builder will build the agents, literally write the code, and then the tools builder will also do the same thing, write all the tools which is needed, and one more agent or the agent builder itself could create a main.py to bring all of these together. That's how this project works. It basically sounds cool that it's an agent which creates an agent, but it's just a rule based agent which, based on whatever, it creates those files, runs them, checks them if it's working, and gets back. So there's a small project which, sad part is it's not completed, so I couldn't show you here. It's still work in progress. It's open source, by the way. You guys can come and maybe ask. We can contribute together. That'll be fun. So the final part of the whole talk, you know how what an you know what an agent is, how they work, how to build good agents. Now, what why the main question is why to build an agent, SaaS versus agent. That's the topic. But yeah, why building an agent? Who will use it? How will they use it? Have you ever asked this question to yourself? Building agents is fine, but who will use it and how will it be used? Applications like Snapchat or Instagram built They're being used by people using an application where you go, you click some buttons and do it. How will that happen with agents? That is the question. And why I feel your agents could potentially transform how SaaS works normally, generally. So, so yeah, let's just understand what a SaaS application is. SaaS is basically a combination of a database and a layer and logic. So there are three components: a database, on top of that some business logic, on top of that a layer, interaction layer, something like a website. So you have a website, you interact with the website. Based on your interaction, some stuff would happen in the backend logic, and that would happen in the database as well. This database would be shown from backend to your front end. That's how it works. Simple example is Google Sheets. It is a SaaS. You can interact it using the website, click on some buttons, create some tables, create some sheets, whatever, and the data servers, I mean, database in the servers would update. And there's more stuff to it, but this is how basically it works, right? What is an agent? An agent is something which can do stuff like a human does. You give it some stuff, like some input, give it some tools, and it could do that stuff for you. They can make things easy for you, right? So, how I think would happen is, let's just take the example of Google Sheets. um, there's a bit of a learning curve there, right? You need to understand the inputs. I mean, if you had computer science or like computer classes in your school, the whole sixth standard was they taught me how to use document and Word document and Excel, Google, Excel sheet, whatever. This learning curve can be reduced, can be reduced heavily. A user would come tell the agent, "Hey, this is the table I need to make. This is the document I need to write." The agent would literally do that, and this would be updated in the servers. So the layer of which I mentioned earlier, right? The interaction layer, like website or mobile application, this could potentially be transformed where agents would do stuff on behalf of you. You would just need to give a natural language command or either a text command or speak. So how or where this is happening? You might have heard of Cursor or Windsurf, right? These are code editors. These code editors, basically, they you type in something and they'll make stuff for you. They'll code literally for you. This is what my Debian was also. My Debian was like a small prototype of this, which I built long back. But yeah, an code editor where you can type, give commands, and it would literally do the coding for you, right? Now there's this application called Super Whisperer, which is like it's only available on Mac, and I have an old Mac, so I couldn't use it. But you basically just speak, and it would go as a prompt for the LLM. It would change a little bit and give it as a prompt for your LLM. It's an LLM in itself. It would change the prompt a little bit and give it to an LLM. So you speak, it'll take in real time and send it to an LLM. So imagine code editor. This is what if you know who Andre Karpathy is. In his latest tweet, he mentioned about vibe coding, where he just sits with Cursor and Super Whisperer. He speaks, and literally the agents are doing the coding stuff for him. He just goes and changes wherever needed. Same thing would happen everywhere. Let's take the example of Canva, where you can create a YouTube thumbnail with this and this text, this color, background should be this color, this should be there. You can literally say that, and this would happen. This is how the future would look like with agents. This is how our parents, or the older generation would use it. This would make the learning of very, very less, and the only thing would be to speak. Obviously there are challenges like English. Not everybody will be using English. We need Kannada or we need Hindi or Telugu or whatever. So we don't have LLMs to do that, right? And they just translate words, so in real time it will be difficult. But that is one stuff. You can take example of video editors. The video editing software has a lot of learning curve. What if I just wanted to create a simple video, edit it? What would I do? I would just come speak, it would edit, look cool, right? It'll be easy. It'll be easy for the users. That's the most important thing in a business, to make the lives of your users easy. That's what I think will happen. Already happened with core editors, probably will happen more. So yeah. Yeah.
Sai,
Hmm.
Before we move, there are few questions, so
Yeah,
I'll
yeah.
bring one by one. Okay, the first question is up on the screen.
Yeah, so a framework, right? Crew AI is the easiest framework From my experience, people use Autogen and LangGraph to do complex and like production level stuff. To do, I mean, you can do the same thing with CrewAI, but it takes like you need to be very careful there. It's very easy to learn. That's one good thing. So if you're getting started, go with CrewAI, learn Autogen and LangGraph later, and it's like easy to switch once you know one framework. So yeah.
Okay, the next question is up.
Tabular output by Pydantic. It's a Python problem. You need to design the schema in such a way that it can give you rows or columns, column-wise data, row-wise data. So it's not a agentic problem. It's more of a Python problem. Yeah, I have left some links in the last slide. You can look into that. There are some repositories which I left the link for, so you can do that. Yeah. Yeah, that's why I don't like CrewAI much because the debugging is very difficult with all the nonsense stuff which it prints, warnings and all, which are not even part of the main process of running. It's just some side dependencies giving out. But to do that, I think it's better to have clear output schemas, and if it isn't matching, then you'll have to go and look into the reasoning trace which the agent gives, read them, and do. There's no proper debugging thing to do for AI agents. So yeah, CrewAI is easier to build. It's very easy to get started. Autogen is a very good platform. If you ask me, it's a very good code base I have been seeing, and it's like too good. Apart from that, Llama Index also has their agents, and Pydantic also has their own framework. So there are a lot of frameworks. Depends on you what you like to choose, and you can always switch between them. It's not a big deal. Yeah, similar to Alexa, but Alexa isn't as intelligent. It was just a rule-based system which would answer. This is much more than that. But yeah, the base Alexa is a very basic version of what an agent would be in the future. No, I haven't looked at Prompt Flow by Microsoft. I think that's the first time I'm hearing it. Probably need to check it out. If there someone can manipulate how can you tell the agents to do? Yeah, so to manipulate an agent, it's prompt injection, which is a very serious concern. Even big companies like DeepSeek couldn't handle that. And LLM security in itself is a topic which is very new, right? LLM, I mean, agents are only a new topic. On top of that, security is a very new topic, and that's one thing. Yeah, even I kind of lack somewhere. What if agents do it in specific time? Yeah, you don't need to tell them. You can set the code right to run an agent that particular time. There are these things called background workers which can run at any specified time. So it's more of a cloud related problem, I guess. Backend issue. Yeah. You can agents to use less tokens. No, you can tell the agents to do what it needs to do, and pray they don't hallucinate, and that works most of the time. So yeah. Yeah, Llama Index is a good framework, but I haven't gone to all those because CrewAI, Autogen, LangGraph, these were enough for me. Um, there's an extent to which you can learn a framework. Right? There are a lot of frameworks coming out. Every day, a new one will come. What you like is that's the only important thing. What you like using, use that. You'll get the same results. Financial modeling, any LLM is better. A reasoning model would be better. Like DeepSeek R1 is cheaper. So if it's me, it's on me, I would go for R1, DeepSeek R1. Yeah, yeah. Time critical, also known as real time, right? If I speak, it should in real time do the execution. Give me. I shouldn't wait. That slow down process. We have real time APIs, and you can build real time agents. That's not an issue. I mean, that wasn't there a few months ago, but now they are coming up. Real time APIs by LLM providers, and these frameworks are also evolving themselves to adapt to these changes. So you have agents which can be in real time. Yeah, same question. They can manipulate using prompt hijacking. So you would have seen some examples about DeepSeek R1. You can search it on YouTube. Prompt injection. Yeah, shouldn't speak more about that. Yeah, this is a very important question. When not to use agents and when to use agents. So if your flow, right, is is predictable. It is a linear process which can be done by LLMs, right? You don't need to use an agent to do that. You can decide the um, pipeline and do it. This is what I tell in my Twitter, like a lot of times. Agents are a thing of the future, right? Now we don't have such LLMs which can do everything. We are not generally intelligent, so it's better not to use agents and to use agents like not as rigid thing. So it's just for automating, not for complex and dynamic stuff. Yeah, it's there in the PDF file as well. I'll just put it in the chat as well. Yeah.
Yeah, thanks.
Yeah,
I
sure.
think that's about it. And yeah, carry
Yeah, I
on.
think there's like 2 3 slides left. Yeah, so I was speaking about how agents would hijack the interaction layer and probably either have a separate layer for interaction only using agents and front end differently, or this could be merged. So front end would have agents as well. You just speak and they would do stuff for you, give you stuff back. And yeah, so the last slide. Wait. Yeah, SaaS versus agent. So there's this video I watched. This person called Devin Kian who builds agents. He talked about it. How we would have two types of agents. Client side. I call it client side. He calls it client user. Right. He calls it custom agents. And this foundational agents. Custom agents are basically the agents which you would have on your device, which you would interact, and these would go to the internet. And so let's say I just say that I need a to-do list on my Google document about some paper deadline which I have. So these agents would interact with the foundational agents. These foundational agents are built by your SaaS providers, so the Google document guy. They would have their own agents. This agent would tell that agent ki, this is what you need to put in the document, and the foundational agent would literally do that, change the thing. That changes literally are happening in the database. That's it on a very layman terms. If I explain, they will do that, and in this way the user hasn't interacted at all with your with your application. It's just via voice, and it's good. Obviously a few platforms like let's say Instagram, they want you to stay on your platform for longer. They won't do this. But some platforms which have task specific, right, like Google Docs or Google Sheet, they don't care about user retention. So stuff like that will be easy. And obviously, since it's open source, a lot of people will come and they'll build a lot of stuff. But these things are in the future. That's why I kept it in the end, and that's the title, was from framework to future. So yeah, that's it. That's the whole session. Links are there. My blog links, Twitter is there. The project which I told, which a few people asked, is here. And the YouTube video which I talked in the last slide is also linked. You can check it out. Yeah, are there any questions or?
Yes, we do. We do. I'll
Okay.
just get them on the screen. Yeah, it's up. The first
Yeah,
question.
when not to use a vector database? That's a good question again. When not to use a vector database, when you don't need to have external memory sources. When your agent is when your task is to create like a journalist who goes to internet, searches stuff, and gives a newsletter. You don't need a vector database there. You just need a tool to search internet. So yeah, so framework assume a single process in order to scale single microservice and distributed system level in the cloud. Yeah, actually, if you assume your agent whole thing as a single thread, like, right, or a single process, in the backend you can have multiple of these processes running for different users. Or that is what we do currently. There is a problem which I think we need to focus, because Um, that means if you have an agentic RAG, for each user there would be different vector databases, different indexes. For each user there would be different from whatever. Like so, that is one problem here. Not dependency injection, but let's say you have this you downloaded Crew AI, some sort of version that requires some dependencies to be already installed in your computer because your Crew AI runs on those dependencies. And there are also some other Python dependencies which don't need these dependencies. So there will be some sort of conflicts. It's difficult to explain, but when you build stuff, you'll realize how this whole mess creates. And yeah, and the whole thing is because of LangChain thing. So yeah, not work the same way always. Yeah, yeah. That is why prompt engineering is very important. The way you structure your prompts, personality, task, and the tools, and you define all of these in the prompts as well. The instructions and the task instructions, what to do, how to do. That's what the founder of Crew AI also mentioned in his tweet. The use case of agents would be one, as I discussed in the last slide. It would make interaction very easy, interaction with new technologies. Apart from that, they would do stuff for you 24 by 7 without, they don't need sleep and all of those, right? So 24 by 7, they would be running. The only cap would be price, cost of tokens. Yeah. Yeah, yeah. But I don't think your GPT-4o has 128K tokens context size. I think that's tokens if I'm not wrong, or words. I think it's tokens. So 128K tokens, 75% of 128K. Let's assume it's 90,000. So 90,000 words is the limit for GPT-4o or 4o mini. This is a lot. I don't think our prompts would be 90,000 words. Max to max 1,000 words would be it. And if you are talking about how to manage this, what I do, I create a separate folder for prompts where I store each prompt for each agent in a separate file. So this gives me a lot of help because let's say my founder for my startup, he wants to do some changes. He didn't like this output. He would literally go to the repository, see the prompt in the prompt folder without going to having the need to go to the code, Python code, search everywhere. It could be for the front end guy also. He could tell me what changes are needed. He could see and suggest me. So this makes it easy, centralized prompt system. No, no, it's better not to use a fine-tuned agent. It's better to use a RAG. So create a vector database with the knowledge which you have. Let the agent give the agent a tool to retrieve, and let this agent do it whenever it needs. And agents are actually LLMs are intelligent enough to do that. They would know when to use a retrieval tool and use it and get the context and give answers.
Think we don't have any other
Yeah.
questions. That was the last question. So thank you so much, Sai. And folks, I hope you have already taken our photo or you've taken down the links that Sai has already shared. But yeah, thank you so much, Sai, for hosting this session. And thank you all for joining us today. Please visit Microsoft Reactor website for more upcoming sessions. And also, we would appreciate your feedback on today's session as it will help us to curate future session. Please scan the QR code and do share your feedback. Today's event ID is 24644. Thank you all once again and enjoy the rest of your day.